23rd February 2026. This morning, the cybersecurity market reacted fast. CrowdStrike fell 7.8%. Palo Alto Networks declined 6.4%. Cloudflare slid 5.9%. Zscaler dropped 5.2%. Okta lost 4.7%. The trigger wasn't a breach. It wasn't a regulation. It wasn't an earnings miss. It was a tool. Anthropic announced Claude Code Security, an AI system that reportedly identified more than 500 high-severity vulnerabilities inside production open-source codebases. Some of those bugs had survived decades of expert audits, automated fuzzing, and community review. The market immediately understood the implication. If AI can reason through entire codebases and uncover what traditional scanners missed for years, what does that mean for the companies built on traditional scanning? The question investors asked this morning was simple. Is traditional security scanning about to be disrupted? Today, we are going to break that down. For decades, software security followed a predictable formula. You write code. You run a scanner. The scanner compares your code against a database of known bad patterns, exposed credentials, weak encryption, common injection points. If it finds a match, it flags it. If it doesn't, the code passes. Simple, fast, reliable. But fundamentally limited. Because the most dangerous vulnerabilities are rarely obvious. They don't sit on a single line of code waiting to be matched against a signature. They are buried deep inside business logic. They emerge only when two separate components interact in an unexpected way. They survive expert review. They survive fuzzing campaigns. They survive years inside production systems without anyone noticing. Until now. Welcome back to Cyber Vault. I'm Sridhar. Today we are breaking down one of the most significant cybersecurity developments of 2026, Claude Code Security from Anthropic. An AI-driven system that reportedly uncovered over 500 serious vulnerabilities in live open-source projects. This isn't just another security product announcement. This changes how vulnerability discovery works. And if you work in security, development, compliance, or anywhere near a codebase, you need to understand exactly what just happened. Let's begin. Chapter 1: The Limits of Traditional Scanning. Let's start with the foundation. Traditional code security tools are known as SAST, Static Application Security Testing. For years, SAST has been the backbone of application security programs. It scans source code without executing it, compares patterns against a database of known vulnerability signatures, and flags what matches. At a technical level, most SAST engines operate using rule-based analysis, abstract syntax trees, taint tracking, and predefined vulnerability heuristics. They are extremely efficient at identifying deterministic issues, hard-coded API keys, unsafe deserialization calls, SQL injection patterns, deprecated cryptographic primitives, unsafe memory handling in C++, and other well-documented weaknesses. Think of it like a spell checker in a word processor. It knows what a misspelled word looks like. It flags deviations from known patterns. But it has no understanding of intent, meaning, or narrative flow. And that limitation matters more than most teams realize. Because modern applications are not single files. They are distributed systems. Microservices. APIs talking to APIs. Authentication tokens passed across boundaries. Conditional logic layered over feature flags. Role-based access checks implemented in one file and enforced, or not enforced, in another. SAST tools excel at detecting isolated, line-level flaws. They struggle when vulnerability is emergent. Broken access control is a perfect example. You may have perfectly written authentication logic in one module and perfectly written authorization logic in another. But if a specific endpoint bypasses a middleware check due to routing configuration, no single line looks vulnerable. The flaw only exists when you analyze how components interact. The same applies to chained authentication bypasses. Or indirect data exposure where sensitive information flows through multiple transformations before reaching an unintended output. Or business logic vulnerabilities, such as price manipulation, privilege escalation through workflow abuse, or multi-step transaction flaws, which do not resemble textbook vulnerabilities at all. Individually, every line appears harmless. Systemically, the behavior becomes exploitable. And this is where traditional scanning reaches its ceiling. It can tell you whether a function is dangerous. It cannot reliably tell you whether the system's logic is dangerous. Attackers understand this deeply. That's why advanced exploitation rarely targets obvious injection points anymore. It targets logic. It targets context. It targets assumptions between components. The vulnerabilities that matter most are not syntax errors. They are reasoning errors. And reasoning is something rule-based pattern matching was never built to perform. For years, this limitation was accepted as a trade-off. SAST was fast, automatable, CI/CD friendly, compliance aligned. It reduced noise around known classes of vulnerabilities and improved baseline hygiene. But it left a blind spot. A blind spot where complex, high-severity vulnerabilities could live undetected for years, even decades, inside production systems that passed every automated scan. That blind spot is precisely what Claude Code Security is attempting to eliminate. Not by improving pattern matching, but by replacing pattern matching with contextual reasoning. And that is a fundamentally different approach. Chapter 2, From Pattern Matching to Reasoning. Now here's where the shift becomes structural. Claude Code Security from Anthropic does not operate like a traditional scanner. It does not rely on predefined vulnerability signatures. It does not simply compare your code to a checklist of known bad patterns. Instead, it attempts to reason. And that word, reasoning, is the key difference. Traditional tools ask, does this line match something dangerous? Claude asks, what is this system trying to do, and where could that intention break? It reads the code base the way a human security researcher would approach a new target. It doesn't isolate files. It ingests the structure. It analyzes relationships. It builds a mental model of how components interact. It traces data flows across modules, following how user input moves through controllers, into services, into databases, through transformation layers, and eventually to outputs. It evaluates authentication boundaries. It examines authorization enforcement points. It observes how conditions branch and how states change over time. It doesn't just look at functions. It looks at behavior. And that matters because modern vulnerabilities are rarely single-function problems. They're multi-step logic problems. A value gets validated in one layer, trusted in another, and assumed safe in a third. Somewhere in that chain, an assumption fails. Pattern matching cannot reliably detect failed assumptions. Reasoning can. Another important distinction is verification. Traditional tools flag issues and move on. That's one of the reasons false positives are such a persistent pain point in AppSec workflows. Analysts spend hours validating alerts that turn out to be non-exploitable. Claude Code Security introduces multi-stage self-verification. It doesn't just surface a finding, it attempts to challenge its own conclusion. It re-evaluates context. It tries to confirm exploitability. It refines its reasoning before presenting the issue. What reaches the analyst dashboard is not a raw guess. It is a tested hypothesis. Each finding receives two independent signals, a severity rating and a confidence rating. Severity answers, if exploited, how bad is this? Confidence answers, how certain is the system that this is real? High severity. High confidence. That's where teams focus. And critically, nothing is automatically applied. There is no autonomous patching engine rewriting production code. Human approval remains mandatory. Developers review. Security engineers validate. Teams decide remediation paths. Human in the loop. Always. This is augmentation, not autonomy. The system identifies patterns that resemble logic flaws. It models risk. It proposes conclusions. But final authority remains with the engineering team. And that balance is important. Because replacing pattern matching with reasoning doesn't just improve detection depth. It changes the philosophy of how vulnerabilities are discovered. This is not a checklist anymore. It's an investigator sitting inside your codebase, continuously asking, what could go wrong here? Chapter 3, The 500 Vulnerability Moment. This is the moment that changed the tone of the conversation. Anthropic's Frontier Red Team reportedly deployed Claude Opus 4.6 against real, production-grade open-source projects, not toy repositories, not controlled lab environments, but widely used codebases powering enterprise infrastructure. The outcome was not incremental. Over 500 high-severity vulnerabilities were identified. Not cosmetic issues. Not style warnings. High-severity flaws. Some of these vulnerabilities had survived years, even decades, of professional scrutiny. They had lived through community audits, corporate security reviews, penetration testing engagements, and millions of automated fuzzing cycles. They were not obvious. They were contextual, logical, emergent. And that's why they endured. Now consider this alongside another reported case, an AI security startup identifying all 12 zero-day vulnerabilities addressed in a 2026 patch cycle of OpenSSL, one of the most heavily analyzed cryptographic libraries in the world. OpenSSL has been examined by researchers, governments, enterprises, and automated tooling for years. It is arguably one of the most scrutinized pieces of open-source software in existence. And yet, AI systems were able to surface issues that had remained hidden. Let that settle. Decades of human expertise. Millions of compute hours of fuzzing. Thousands of community contributors. And AI reasoning models surfaced critical vulnerabilities in days. This is not incremental improvement. This is a step function change in how vulnerability research can operate at scale. We are no longer talking about automation that accelerates manual review. We are talking about automation that performs investigative reasoning across entire codebases continuously. This is AI-powered vulnerability research at codebase scale. And that has implications far beyond one product announcement. Chapter 4: The Dual-Use Reality. Now we move into the uncomfortable part. The same reasoning capability that enables defenders to discover deep logic flaws can enable attackers to do the exact same thing. AI does not understand morality. It understands structure, dependencies, control flow, data flow, assumptions. If a reasoning engine can model exploit paths for defensive discovery, it can model exploit paths for offensive targeting. This is the core dual-use dilemma of AI in cybersecurity. For years, attackers have manually reverse-engineered systems to find logic flaws. That process required skill, time, and persistence. AI reduces that friction. It lowers the barrier to systematic vulnerability exploration. If defenders hesitate to adopt AI-assisted discovery, adversaries will not. The competitive advantage does not remain neutral for long. The race is no longer humans versus machines. It is defenders equipped with AI versus attackers equipped with AI. And the most critical metric in this race is time. Time between vulnerability introduction and discovery. Time between discovery and patch. Time between patch release and exploitation in the wild. The patch window has always been a race. AI just compressed the timeline on both sides. That compression forces organizations to rethink response velocity, validation workflows, and remediation pipelines. Speed is no longer optional. It is strategic. Chapter 5: What this means for SOC and AppSec. If you operate inside a SOC, AppSec program, DevSecOps pipeline, or detection engineering team, this shift is operational, not theoretical. First, AI-powered vulnerability discovery is no longer a research experiment. It is a deployable capability. That means security programs must evaluate how AI-based analysis integrates into CI/CD pipelines, ticketing systems, and remediation workflows. Second, rule-based SAST alone is insufficient as a primary discovery layer. It remains valuable for hygiene and compliance alignment, but it cannot be the ceiling of visibility. Third, false positives become a strategic metric. AI systems that self-verify findings and provide confidence scoring directly impact analyst workload. Reduced alert fatigue increases remediation efficiency. In large enterprises, this alone has measurable economic impact. Fourth, speed becomes the baseline expectation. If AI can reason through millions of lines of code in hours rather than weeks, executive leadership will recalibrate expectations around vulnerability assessment cycles. And finally, detection engineering must evolve in parallel. As AI-generated code proliferates, we will see new classes of vulnerabilities introduced through automated development workflows. As AI discovers deeper logic flaws, adversaries will attempt to operationalize exploitation faster. That changes telemetry patterns. That changes threat modeling. That changes what normal looks like in runtime behavior. Security baselines are shifting not gradually, but structurally. Chapter 6: The Market Reaction. Financial markets are sensitive to structural shifts. When Claude Code Security was announced, investors reacted immediately. Several major cybersecurity vendors experienced notable declines in market value. The interpretation was clear: AI-native code analysis could disrupt traditional static analysis and application security markets. But market reaction does not always equal market outcome. Application security scanning is one segment of a much larger cybersecurity ecosystem. Endpoint detection, cloud posture management, identity governance, runtime protection, and network defense operate in distinct layers of the stack. AI reasoning applied to code scanning does not instantly replace those categories. What is more likely in the near term is integration. AI-native tools feeding findings into existing CM platforms. AI-assisted code analysis integrated into DevSecOps pipelines. AI-derived risk scoring influencing vulnerability management prioritization. The sell-off reflected investor concern about displacement. The more probable outcome is transformation. This is not extinction. It is evolution. Still, the signal is unmistakable. This is not a feature enhancement. It is a category shift. Chapter 7: Will AI replace traditional security tools? Now we confront the core question. Will Claude Code Security replace traditional tools? The answer is no. But it will redefine their role. Traditional SAST tools remain valuable for deterministic, known pattern detection. They are lightweight, cost-effective, and deeply integrated into CI/CD ecosystems. They align with compliance frameworks such as SOC 2, ISO 27001, and PCI DSS. They function in restricted and air-gapped environments. They require far less computational overhead than large AI reasoning models. They provide speed and coverage for known classes of weaknesses. Claude Code Security provides depth. It uncovers complex, logic-based vulnerabilities that pattern matching cannot reliably detect. It understands full codebase context. It reduces noise through self-verification. It operates like a senior security researcher reviewing architecture, not just syntax. Think of it as layered intelligence. Traditional SAST is a spell checker. Claude Code Security is an investigative analyst. You do not remove the spell checker when you hire an analyst. You combine them. Rule-based tools for rapid hygiene. AI reasoning engines for contextual depth. Human expertise for judgment and remediation strategy. Replacement is unlikely at enterprise scale in the immediate future. However, in smaller and mid-sized organizations that currently rely solely on basic or free scanning tools, AI-native platforms may become a direct upgrade path. In those environments, displacement is more plausible. But broadly speaking, traditional tools are not obsolete. They are incomplete. And the future of security is not AI only. It is AI augmented. Final, the direction of cybersecurity. Claude Code Security is currently in limited preview. But the broader narrative extends beyond a single product release. AI is embedding itself into every stage of the security lifecycle: vulnerability discovery, code review, detection engineering, incident response, and risk prioritization. The vulnerabilities that survived decades of human and automated review are being uncovered in days by reasoning systems operating at scale. That changes expectations. It changes velocity. It changes competitive positioning. The question is no longer whether AI will reshape cybersecurity. It already has. The real question is whether defensive organizations are adapting at the same speed as the threat landscape. This is Cyber Vault. I'm Sridhar. If you want deep, technical breakdowns of the technologies reshaping security, subscribe to Cyber Vault. Because the most dangerous gap in cybersecurity is not in your firewall. It is in your awareness. Stay informed. Stay ahead.